Welcome, Molo. This presentation sketches the context of the 2050 Pathway Calculator for South Africa, as available on the website of the Department of Environmental Affairs. The context for climate change mitigation, the avoidance and reduction of greenhouse gas emissions. In an economy dominated by coal, as shown in this snapshot of the energy supply system as in 2006, the most recent year for which there is full official data, published in 2010. On the left is primary energy supply. On the right is energy available at the point of use, with an illustrative depiction of losses in transformation, including GTL and CTL, that is, gas and coal to liquids. In an assessment of mitigation potential, we explore how to transform this system as deviations from a hypothetical future in which coal would continue to dominate, as shown here from 2010 to 2050. South Africa has agreed to present our mitigation objectives, or intended nationally determined contributions to global efforts, to keep global warming below 2 degrees Celsius, with other parties to the UN Climate Convention, this year, before the negotiations in Paris in December. A national conference in 2005 initiated policy development, and South Africa's National Climate Change Response White Paper was adopted by government in October 2011. It recognizes the need for profound changes within our economy and energy system, and stipulates a range within which national emissions should remain to 2050. Setting a limit on our national emissions trajectory or pathway called Peak, Plateau and Decline, or the PPD range. In all the graphs, the horizontal axis is time to 2050. The vertical axis here is greenhouse gas emissions annually. This PPD range is depicted in the 2050 calculator emissions graphs as a green band superimposed on emissions projections. This disappears when using the zoom function. The National Climate Change Response Policy does not directly address cumulative emissions to 2050, but subsequent documentation provides annual totals for the high, mid and low trajectories to 2050, giving a range of totals from 14,830 megatons to 23,065 megatons CO2 equivalent, or roughly 15 to 23 gigatons. We currently emit over 550 megatons per annum, or over half a gigaton. Policy documentation for the elaboration of mitigation measures states that mid-PPD, which has a total of almost 19 gigatons, should provide the basis for developing desired emission reduction outcomes, or DEROs. Such a trajectory may look like this on the pathway calculator. An official report on South Africa's emissions in the first decade of the 21st century was published in 2014 in November. The inventory reports total emissions reaching 544 megatons in 2010, with attributions to waste, agriculture, forestry and land use, industrial processes and product use, and energy, that is, energy supply and use, which accounts for over 80% of national emissions. Following the International Convention, emissions are reported in gigagrams, which are the same as kilotons. So 1,000 gigagrams equals 1 megaton, 500,000 gigagrams, 500 megatons. Emissions attributable to energy supply and use are shown here, broken down by sectors. For example, fuel use in transport is shown in green. Electricity generation accounts for about 45% of total national emissions. Absolute sectoral figures are provided in a table showing how net emissions in the right-hand column are understood to be lower than total emissions, second from right, as some forestry and other land use activities serve as a sink, estimated to remove 26 megatons from the atmosphere in 2010 to yield a net total emissions of 518 megatons in 2010. This is a substantial downward revision from the earlier draft inventory, which put reported net 2010 emissions at 563 megatons. To get a sense of how the emissions projections generated in the 2050 Pathway Calculator relate to national policy, we can plot hypothetical trajectories with the same cumulative totals as the high, mid and low of the PPD range, here all starting from emissions as reported for 2010. These pathways remain within the range to 2050. The area under the year-on-year trajectory represents the implied carbon budget. Going no lower than 212 megatons, the low end of the policy range for 2050, with an anticipated population of 70 million people, would result in per capita emissions, the national total divided by the number of people, of 3 tons per person in 2050, at least 3 times what the global average should be. If we release the constraint at 2050, we can plot a trajectory for a smoother transition, arriving at a far better endpoint, with per capita emissions down to about 1.3 tons per person per annum in 2050. As a developing country, we expect to be allowed to remain above the global average. However, other developing countries have suggested that South Africa's carbon budget to 2050 should be below 10 gigatons, for which an hypothetical trajectory has been added to this graph. Those 3 trajectories are shown here to the left, approximately to scale with the calculator reference case. The PPD range was derived from the Long-Term Mitigation Scenarios, or LTMS, which was endorsed by Cabinet in 2008. Following adoption of the White Paper in 2011, a more detailed and bottom-up study was commissioned. The Mitigation Potential Analysis, or MPA, published in November 2014, identified a set of mitigation actions for which sufficient data was available to model the likely macroeconomic and social impacts of implementation. The extent of mitigation or abatement actions identified for analysis is shown here as avoided emissions from a baseline or reference case. The baseline reference case is shown here with sectoral allocation. Projected emissions, only very slightly lower than in the LTMS projection, assume strong growth in industrial emissions, the deep red area in the graph. Emissions that remain, assuming implementation of all mitigation opportunities identified for analysis in the MPA, appear at the bottom of this graph, rising to a total of 740 megatons per annum in 2050. The MPA does not assess all possible abatement actions or the full technical potential for mitigation. For example, the electricity supply mix from 2030 to 2050 was fixed, maintaining the 2030 proportional shares as envisaged in the IRP 2010 plan for electricity supply. Subsets of the mitigation options are assessed in terms of various criteria to assess their net social benefit, additional to avoided climate change impacts, and compares outcomes of implementing different packages of the identified actions. The results of socio-economic modelling of different portions of the mitigation potential can be found in the full MPA report, which is available on the website. environment.gov.za. The Pathway Calculator provides emissions projections for the economy as a whole, as well as emissions from electricity supply only. The national projection, generated from 2006 and smoothed by modelling, is somewhat lower than that developed for the mitigation potential analysis, as recently updated data has been applied, as well as the latest assumptions regarding economic growth. The calculator, without the constraint applied to the MPA, can model complete decarbonisation of electricity supply by 2050, as shown on the right. This would utilise mitigation potential not included in the scope of the MPA modelling, including 460 megatons in 2050 from coal-fired electricity generation. Thus, full decarbonisation of electricity would bring emissions below mid-PPD. In November 2013, the Department of Energy published for comment an Integrated Resource Plan, or IRP, update report. This modelled an electricity supply pathway with emissions declining to 140 megatons in 2050, though this has not been approved as a policy document. The emissions graphs in the Excel version of the 2050 pathway calculator provide a detailed sectoral breakdown of emissions, here showing total decarbonisation of the power sector with some negative emissions from carbon capture and storage being applied to liquid fuel supply emissions. Unlike the fairly smooth projections generated by the calculator model, starting from 2006, actual emissions can be expected to surge in the short term as Medupi and then Kusile come online, two coal-fired power stations each emitting about 30 megatons per annum when running at full capacity. The reference case projection is not offered as a credible scenario for South Africa's energy development. Nobody suggests we could burn such vast amounts of coal to 2050, regardless of climate change, given other impacts on water, air quality, etc. From a carbon budgeting perspective, it is clear that we should not use all the coal we have, even our listed reserves. A report published in 2012 reviewed the carbon content of South Africa's identified coal reserves and resources, i.e. emissions that would result if it is burned, shown in the column on the left. The potential emissions from coal already listed as reserves on the stock exchange would be greater than the total emissions of the mid-PPD pathway at just over 19 gigatons. This coal carbon is compared to 4 potential carbon budgets for South Africa, the 4 columns on the right, with 2/3 of total budgets allocated for coal. For example, the total national budget of 18 gigatons, far right, would not accommodate more than 12 gigatons of emission from coal from 2010 onwards. It is thus important to explore truly transformational options, such as illustrated for the power sector in this electricity supply projection produced in the Excel version of the calculator, with over 95% renewable electricity by 2050 and about 4% gas. We hope you enjoy exploring emissions pathways with this educational tool. Project 90 by 2030, a Cape Town-based NGO, is responsible for this presentation of our national context, produced by Richard Worthington as part of the piloting project funded through the British High Commission in Pretoria. Thank you.